Hello all. In this particular video, we will be discussing on the stepper motor interface. This is one of the topic that as per the syllabus, VTU is asking you to interface with our device 8051. Microcontroller can control a varieties of the devices. Here, one such example is a stepper motor. What we are doing is, we are trying to rotate the stepper motor into two different directions, that is, we are describing it as direction of rotation. The stepper motor can rotate in two directions, that is clockwise and counterclockwise direction. Okay. For rotating in this direction, a user need to write a program. Before we write a program, it is our duty to understand how the basic motor is basically constructed. Here, we are taking the simplest form of a stepper motor, that is, it has a stator and a rotor. Stator has 4 windings. Okay. I am naming them as A, B, C and D and it has a rotor winding permanently. So, north and south pole are established once they get a power supply. Okay. So, north and south poles are permanently established once the power supply is on. So, the motor, if I am writing a rough sketch for the motor, it would look something like this. I am just writing a rough sketch. So, here I will be writing coil A, coil B, coil C and D. These are the stator windings. At the same time, we have a rotor winding also. Okay. So, as I told you, this rotor is permanently magnetized. So, I am establishing a north and south pole. Okay, this is pivoted against an axis. This is a simple construction of a stepper motor. What are we doing? I am simplifying the process. Okay, let us not go deep into the calculation part. I am going to give you the easiest way of writing a program for a stepper motor, direction control. What am I doing? First, I will energize coil A. Energizing in the sense, I am sending a high pulse. So, rest B, C and D all are zeros. Correct? Now, what happened? North pole is established in A, hence north and north pole here ripples. I will proceed the same. Here the sequence, if I write in the form of a sequence, it is 1, 0, 0, 0. The same way, if I am writing a sequence, for the next step, what will I do? I will energize B coil. I will energize B coil by sending 1. So, north pole is established at B, rest are all zeros. Correct? Now, the sequence will be 0, 1, 0, 0. Correct? So, next step. What will I do? I will just establish an north pole on coil C. Rest of the bits are zeros. So, sequence will be 0, 0, 1, 0. Last step, I will establish 1 for D coil. Rest of the bits are 0. So, 0, 0, 0, 1. If I am writing a sequence, overall, so I will have A, B, C, D. First A was energized, next B will be energized, next C, lastly D. Okay. So, since I am handling with 8-bit ports, so easiest way is to replicate it, so as to make it as 8-bit. So, I will just write the same sequence. So first value is how much? 8421 code, correct? Hexa. So it is 88H. And you can also observe the data 1 is shifted towards right. Correct? So this is going to give me a clockwise rotation of the motor. Correct? Now next, let us go to the other way of rotation. So what will I do? I will first energize D, north pole. So motor will be repelling north poles. So sequence is 0, 0, 0, 1. Later, I will energize coil C, north pole. So sequence is 0, 0, 1, 0. Later, next step, I will energize coil B, establishing north pole. So sequence will be 0, 1, 0, 0. Lastly, I will be energizing the coil A. So sequence will be 1, 0, 0, 0. So you can see I am shifting the energy in this direction, which is nothing but anti-clock or counterclockwise direction. Writing the sequence here, I will have A, B, C, D, A, B, C, D. First I energized coil D. Next I will energize coil C. Next I will energize B. Lastly, A. So if you see, first value is 1, 1H. And if you see the sequence, I am rotating the sequence towards left. So the system will rotate in anti-clockwise direction. Simple. So if I want clockwise rotation of motor, I'll start the motor with sequence 88H and rotate right for 4 steps. Similarly, when I want anti-clockwise, I will start the motor with 11H, rotate left for 4 steps. This is the basic logic that I can derive. So coming here, this is what I was talking about. So I have north pole, okay, coil A, coil D, B and C. Okay, so we have a rotor part also here, correct? So we have to rotate the motor in clockwise or anti-clockwise direction. So I am writing the sequence like this. Okay, either 1 by 1 coil you can energize, or you can energize it in 2 coils, 2 opposite coils can be energized together. This example I am taking where A and B are on a common point, C and D are on a common point. That means if I am energizing A, D should be done. If I am energizing, it should be basically done in the combinations, correct? So this is the way the motor is basically connected. Okay, I am having the coils here, 2 coil sets here. Okay, it is unipolar stepper motor. I want a stepper motor power supply or a driver circuit. Why? The voltage requirements are different to that of your microcontroller. I am using 4 pins from a microcontroller to energize the stator part. So I will be sending different sequences, say 1, 0, 0, 0. It rotates. Later I will send 0, 1, 0, 0 and it rotates. Hope the concept of stepper motor, what we discussed in today's class, in today's session, is useful. You can write a C program for this, for doing this operation of starting the motor with different value 88, rotate right with 4 steps, or write 11, rotate left with 4 steps. This process is useful to you. Thank you.